Okay, hello everyone. Welcome back. This is Professor Lai. So this video is for chapter 11, inventory management. All right. So probably as you know that inventory is one of the most important topic within the operations management procedure. So that's why here we use the whole chapter to talk about inventory management. We will talk about many different quantitative and qualitative methods within the inventory management procedure. All right. Now let's start to talk about today's main topic. So here comes the learning objectives. All right. So even before we start to talk about those different quantitative and qualitative methods within the inventory management procedure, now we should start from learning what is inventory, right? And what are the common inventories within this whole procedure, and what are the common costs that may incur within, that is dealing with the inventory. Okay, so these are some fundamental, basic, but also very important, concepts that we need to understand about the inventory before we move to those inventory management methods. All right. After we get a good sense about, what is the inventory, what are the common costs related to the inventory, then we start to talk about many different quantitative methods within the inventory management procedure. All right. So we were talking about what are the relationship and what are the difference among different inventory management methods. All right, and what are the which inventory management method is more fit for what kind of situation or what kind of applications. All right, so we will detailedly talk about every quantitative inventory management methods, and we will also talk about the relationship among those different methods. All right, so that would be the second objective. The third objective will move to those qualitative inventory management concepts or methods. All right. So I will briefly talk about those different methods, and more details will be shown within the textbook. Okay. So for more details, you need to just look at the textbook. It will give you a very good description about those qualitative inventory management methods. All right. Now let's start to talk about from the inventory concepts. All right. So as you can see here, okay, actually the inventory definition is very straightforward. What is inventory? Inventory can be visualized as stacks of money sitting on forklifts, on shelves, and in trucks and planes while in transit. All right. So from this definition, you can already see that actually inventory itself, can actually count for many different things. Okay, within the whole production procedure. All right. So let me give you a good sense about what is the inventory, right? So let's say you are a firm, all right? So you are trying to produce certain type of product, all right? But in order to produce a certain type of product, you have to buy some raw material from the supplier, all right? And then the supplier, all right, will transit the raw material, let's say by truck, all right, or by airplane, all right, from his factory to your own factory, all right? After those raw material come to your factory, all right, you probably will reserve some space to store those raw material before you start to produce your final product by using those raw material, right? And then once you start your production process, right, you will use those raw material and probably also together with some other raw material, and then you start to produce your own final product. All right. After you produce those final products, you probably also need to store your final product at some other place within your factory before you transit or you move your final product to a retail store. All right. And after your final product is transit to your retail store, you probably also take some time, before you can actually put it or your final product onto the shelf, and which is ready for customer to pick up. All right. So you see that actually this is a whole procedure of the the operations management process. All right. But actually, many different things are counted as the inventory during this whole procedure. Let's start from the beginning. All right. So when you decide to buy certain raw materials from your supplier, okay, once this raw material transits, okay, from their supplier's factory to your own factory, they already become your inventory. All right. And after those raw material come to a warehouse, all right, they are still there your inventory, all right. And then once those raw material is used by your by your production procedure to produce some final product, all right, those things, those materials are also counted as your inventory, although the name is different. Okay, at the beginning we call it as raw material inventory, but here we call it work in process inventory. Okay, and after you produce your final products, all right, those things will be stored or still within your warehouse, right? Those are still counted as your inventory. Those inventory are called final product inventory, or we say even say it's a preparation inventory. All right, and then let's say, okay, the retail store orders some new product from your factory to go back to the retail store, no matter during the transition procedure or on shelf of the retail store. Those inventory are also basically those goods are also your inventory. Okay, so we can say it's retail store inventory or some other different names. Okay, and so basically, before the customer pick it up, before the customer purchase this specific product, okay, you can see that all these different materials or the work in process goods or even the final goods are all counted as your inventory. Okay, but you see that actually those different goods are in the different stage of the production procedure, but all of them are counted as inventory, as your inventory. All right, so you see that's why inventory is actually very important, right? So within your whole production procedure or your whole production line, all right, starting from the preparation to the middle production point of view, and then to get ready for sale point of view, you see inventory is everywhere. That's why we have to monitor inventory very carefully in order to get a good, better sense about where is the inventory level within our firm and how we can improve our inventory efficiency in order to save some money. All right, so that's just giving you a basic sense about what is inventory, what kind of things can be viewed as inventory. All right, basically inventory is everywhere. All right, as I just said. So that's why here you see that for many business, inventory can be the largest asset, okay, on your balance sheet at any given time. You have to monitor it very carefully. All right. Um, and as I say here, inventory sometimes is very difficult to convert back into cash. Right. We know that inventory is a very important asset on your balance sheet. All right. But your final goal basically is trying to to sell all your inventory, all right, and make it convert it back to the cash flow, right, such that you can produce some more and new products, right, and give it back to customer, and basically you can get some new cash flow in order to smoothly um, repeat this whole production process and even improve and expand your production level. Okay, so that's why the conversion of inventory back to the cash flow is quite important. All right, but sometimes it's very difficult. Okay, sometimes it may be the inside reason. Okay, because of because that your product is not that attractive as other competitors' products. All right, or sometimes it can be the outside reason because of the outside economic situation, right? Sometimes when the economy within the society is not that good, then people may not that willing to buy some new stuff. That's why here sometimes the inventory is very hard to sell for the customers. Okay, in those difficult situations. Okay, so that's why here, as a firm, right, for outside situations, it's a little bit harder to kind of to deal with. Okay, but at least as a firm, we can try to make our inventory as low as possible. All right, in order to incur less cost during this whole procedure. All right, but it doesn't mean that inventory itself is not good. Sometimes actually in most cases, inventory itself is very, very important. Okay, you can view inventory as a buffer. All right, in order to prevent some uncertainty. Okay, in general. So that's why actually firms are very, very emphasize the importance of inventory, but also try to decrease the inventory level into appropriate range. Okay, that's what we want to deal with within this whole chapter. All right, we need inventory, but we want to make the inventory as an appropriate level. Okay, so let's look at the a diagram, a basic diagram. All right, of the inventory within the supply chain. The whole supply chain procedure. All right, so this is actually similar as what I just mentioned. All right, so inventory can be everywhere within the production procedure, all right, starting from as a raw materials, right, as a raw materials, and then you probably will start to produce some final product by using those raw materials, right. So in the production procedure, okay, those inventory are viewed as manufacturing plant inventory, or we can say work in process inventory, all right, but those things are also inventory, all right, and after you finish the production procedure, right? Then those inventory are moving from the working in process inventory to the finished good inventory, okay, the finished product inventory. And since all those inventory are sitting in your warehouse, all right, that's why we call it warehouse inventory, just by giving another name for it, right? This is called a warehouse inventory. And then after the retail store orders some new product, you probably will transit your warehouse inventory from your factory to your retail store, right? Then it will they will become the retail store inventory, okay? And once it becomes retail store inventory, now those inventory are ready for sale, right? Those are ready for those customers to pick up. So you see that inventory is everywhere within this whole production procedure, or more generally, we say in the whole supply chain operations management procedure. Okay, so but the key sense of here, you see, this is exactly following how a finished product is made and how will transit to the retail store. This is basically following the whole supply chain procedure. All right, so within this chapter, all right, we will mostly focus on these two inventory, okay, the retail store inventory or the warehouse inventory. So the basic idea is very simple. Basically, those two inventory, no matter it's in your warehouse or retail store, right, they are the finished good inventory, right, because you already finished the production procedure, right. So warehouse inventory and retail store inventory, they are already after you complete the production process, okay. But for the manufacturing plant inventory or raw materials inventory, they're either before you produce or during the procedure of the production, right? So these two inventory are the main thing that we will deal with within this chapter, all right? And in chapter 9, when we are talking about MRP, which is material requirement planning, we will more focus on those two different kind of inventory, okay? Which are manufacturing plant inventory or work in process inventory, or this raw material inventory. Okay, here what we are talking about are mainly dealing with the retail store inventory and warehouse inventory. Okay, let's make it clear before we start today's main models. All right, so let's move to the inventory models. Okay, so these are the three quantitative models that we will mostly deal with within this chapter. All right, so they're called single period model, fixed order quantity model, and fixed time period model. All right. So, in general, okay, no matter this is which inventory models, we can separate into two different categories. Okay, the first one is actually itself is a category, the single period model. Okay, the single period inventory management model itself can be viewed as the classification one. All right, and then fixed order quantity model and fixed time period model, both of these two models are included within the multi-period model. Multi-period model. Okay, so you may wonder what is the key difference between single period model and the multi-period model. Okay, actually the difference is very straightforward, very simple. All right, so if we are talking about an inventory model, okay, that will order certain products only once. Okay, only once, then we are talking about single period model. Okay, but let's say if we are talking about an inventory management model that we will order, a certain product. Okay, we will order certain products repeatedly or regularly in a whole period of time, all right, then we're talking about multi-period model, okay, multi-period model. So that's actually very simple to differentiate, okay. And in the multi-period model, we will mainly talk about these two, fixed order quantity model and fixed time period model, okay. We will first talk about, fixed order quantity model, okay, and then talk about fixed time period model. The key is that what is the difference between these two different kind of model, okay. First of all, the key difference is very simple. The fixed order quantity model is that in this, let's say in this period of time, all right, since you will order certain amount regularly, right, each time when you order, okay, the order amount itself is fixed, okay, but the time period, okay, the time period of each order event is a variable, okay, is variable. That's the key point of fixed order quantity model. Then the fixed time period model is actually the opposite. It's the opposite way, okay. What is key? What is key feature for the fixed time period model? So in this whole, session, or in this whole period, all right, let's say 3 months or 4 months or even 1 year, all right. So the time period for each time you order order a certain amount, all right, this time period is fixed. Okay, give you a quick example. Maybe you order a certain amount of the product at the end of every month, okay, at the end of every month. So the time period, okay, that each time you order certain amount, okay, is fixed. But each time when you order, the order amount itself is variable, okay, is variable. So you see that actually the key feature of fixed order quantity model and the fixed time period model are exactly the opposite, okay. In fixed order quantity model, the order amount that each time you purchase is a fixed amount, okay, but the time period, the time length, okay, between two order behavior, the time window itself is variable, okay. But in the fixed time period model, the time period, okay, of two order events is a fixed time period, but the order amount, okay, that each time you order, the order amount itself is a variable. You see the difference between these two, right? The key feature is actually opposite. Okay, we will detailedly talk about the fixed order quantity model and fixed time period model, okay, and detailedly talk about in which situation fixed order quantity model is more feasible, in which situation fixed time period model is more fixable, okay. But now we will start from the single period model, okay. Single period model actually is kind of simpler because you only consider one time ordering procedure, okay, just one time ordering procedure, okay. You don't care about how this ordering procedure will affect the next period procedure, okay, next period ordering procedure. You only care about one time ordering procedure, okay. So that's why here you see this is used when we're making a one-time purchase of item. That's it, all right. But in a multi-period model, since your order behavior, each time your order behavior will affect the next period, right? That's why here by using fixed order quantity model and fixed time period model, it will give you different results, different situation. All right, that's why we have to consider, right, in one specific application, which model is better. That's actually very important. All right, now, okay, before we start to talk about those three models, okay, let's get back a little bit. All right, we already talked about what is the inventory, right? We say that the inventory is the stock of any item or resources used in organization, right? It can include those raw materials, the work in process products, right? Finished product, or those products that are ready for sale. Those are all different kinds of inventory, right? Or from the manufacturing point of view, right? It can be referred to any items that contribute to or become part of a firm's product. Okay, So these are just some basic idea of the inventory that we already mentioned. All right. So the inventory system. Inventory system is a set of the policies and controls that monitor the levels of inventory. Okay, we all know that inventory is quite important within the firm. That's why in most of the business, okay, the firms will set up a lot of different policies or controls in order to better monitor the inventory level. Okay, because inventory level itself is very important, we have to use the very careful monitoring procedure in order to improve the inventory efficiency, right? Um, we don't want the inventory to be too low because we have in that situation we will face high uncertainty, right? But in the meantime, we don't want the inventory to be too high because by adding too many inventory, you have to store those inventory, right? That will incur more cost for you. Okay, remember that our final goal is to maximize the profit for the company, right? So that's why here when the inventory level is too low, it's not good. When the inventory is too high, it's also not good. Okay, that's why we want to use the inventory control system in order to better monitor and improve the inventory system efficiency. Okay, that's the reasoning. All right, so okay, yeah. So the purpose of inventory. Okay, so as I just mentioned, actually the reasoning of inventory is quite straightforward. It's very intuitive, right? So as I said, inventory itself can be viewed as a buffer, okay, in order to prevent uncertainty. All right. Although the source of uncertainty can be different, as I show here, okay. Actually, here what I show is basically are different source of uncertainty that we have to deal with, okay, in the real business. That's why we really need inventory as a buffer, to face those uncertainty, to decrease in some extent to decrease the damage, okay, caused from those uncertainty. Now let's look at some of them. All right. First of all, record to maintain independence of the operations. Okay, this is actually very straightforward. To meet variation in product demand. All right. So you may remember that in chapter 3, we actually talk about different forecasting methods, right? So we say that, okay, we use different forecasting methods in order to better predict the market demand, okay? But even with very sophisticated forecasting methods, we still know that we cannot 100% sure what is the market demand realization of certain period of a certain season, right? So the demand itself is still uncertain. All right. That's why in most cases we really need inventory. Okay. Let me give you a quick example. All right. So let's say you produce 20 units. Okay. In order to prepare for this specific season. Okay. Of the certain product. All right. If the demand is, let's say, is 15. Okay, then you're good, right? If the market demand is 15, then you're good because your production level is 20. 20 units itself is already above those 15 units of the market demand. Uh, the market demand for that specific product, right? But in the other case, if the market demand is not, let's say, it's not 15, it's 30, okay? But if you only produce 20, basically your market demand itself is higher than your production level. Okay? In those situations, if you don't have inventory, then you lose those, profits in opportunity, right? Because you don't have inventory, then although the market demand is 30, but you only have 20 units in your hand, you can, the only thing that you can do is basically to give those 20 to the market demand in order to fit for customer needs, right? But for the another 10 units, you cannot do anything for it. That's why we really need inventory. Okay, we really need inventory because we don't actually want to have those uncertainty, want to lose some money due to this uncertainty. Okay, so this uncertainty is from the demand fluctuation. It's from demand fluctuation. Okay, but we may actually have some uncertainty from other source. This can be another source to allow flexibility in production scheduling. Okay, So let me give you a quick example about this reasoning. Okay, so maybe you plan to produce 20 units in order to fit for the market demand. Okay, in this specific period, but we know that sometimes even if you plan to produce 20, it may not be the case that you exactly produce 20 units, right? Even if you use the machine directly, okay, without any, let's say, workforce, okay, without any workforce. Okay, so let's say in one case, you plan to produce 20 units, okay, and let's say the market demand is exactly 20 units, okay. Let's say if you forecast the market demand exactly, which is 20 units, okay, and you plan to produce 20 units to fit for the market demand, all right. But in reality, if your production procedure only produced 18 units, all right, then you can, without inventory, you can only sell this 18 units to the market, right, in order to feed that market demand. But for the another 2 units, you basically lose those profit in opportunity, right? That's why here inventory can be also very useful, okay, to basically allow you to have some flexibility in this whole production scheduling. Okay, give you another example. Okay, sorry, the next thing, to provide a safeguards for variation in raw material delivery time. Okay, so this can be another source, another reason why we really need inventory. All right, so in the first 2 example, what I just gave to you, all right, it's basically to mitigate the demand uncertainty. It mitigates your production scheduling uncertainty. Okay, but even if these 2 procedures are perfect, okay, you perfectly predict the market demand, you perfectly schedule your production, okay, you may actually have some other uncertainty, okay. Let me give you a quick example to illustrate this point, all right. So we know that sometimes even if we produce some final products, we still need the raw material from from your supplier. Okay, let's say we plan to get the raw material from our supplier, let's say in 1 week. Okay, but if the supplier used 2 weeks to transit the raw material from their factory to your factory, okay, then without inventory you cannot do anything, right? Without inventory of those raw material, you cannot do anything in order to produce the final product. Okay, then actually this material delivery time itself will cause some damage, because without those raw material, you cannot produce final products, and since you cannot produce the final products, right, you may actually miss the production scheduling, right? You cannot fit your market demand. So you see that actually the uncertainty is everywhere within this whole production or transition procedure. All right, and inventory is viewed as a buffer, okay, also in this whole procedure, in order to help you, okay, prevent from damaging caused by all those different reasons. Okay, that's why we really need inventory. Okay, so ideally, if all those inventory showing here, okay, disappears, then we can say, okay, inventory is not that useful. We don't need inventory, because we can perfectly predict the transition time. We can perfectly predict the production amount. We can perfectly predict the demand realization, such that we know how many products we need from the market. We know what we can produce in our product. We know in how much time we can get the raw materials. Then we can perfectly fit the whole procedure requirement. Okay, but we know in reality this is not the real case, right? This is not the real case. Many unexpected things may happen due to this whole procedure. That's why we need this inventory to make it as a buffer. Okay, now here comes the inventory cost. Yes, so from this slide, okay, basically what we are talking about is that inventory itself is very important, right? It's basically helping us to mitigate the damage from the uncertainty, okay? But it doesn't mean that inventory, the larger, the better, okay? It doesn't mean that if I keep, a lot of inventory within my warehouse, it's the best scenario. No, that's not the case. The reason is that inventory will incur some costs, right? Inventory will incur some costs. Here, I list 4 different common costs that are incurred within the inventory management procedure. Okay, let me give you a brief explanation about it. First of all, the most common inventory cost is called holding cost, right? It's actually very intuitive. Each time when you, let's say when you produce some more final products, right? Before you can sell to the market, you have to store those inventory, right? Then you need space to store those inventory. You need, you have to handle it. You have to make insurance for those final products. So the holding cost itself is very common for those inventories, right? As I show here, it can be, those are related to cost for storage, the handling, or insurance related inventory. Okay, so inventory cost, the first common type of cost within inventory cost is called holding cost. Okay, the holding cost. The second one, setup cost. Okay, or we call it production change cost. Okay, so each time basically when you arrange some specific equipment setups or some workforce setup, you need to incur some certain costs. Okay, those are another type of inventory cost, which is called setup cost. Okay, or ordering cost. Okay, ordering cost is also a very important type of inventory cost. Okay, as I just mentioned, so each time, let's say you are buying some raw material from your supplier, right? You're buying from your supplier. Then each time, basically, your supplier probably will use truck or even airplane to basically move their raw materials from their factory to your own warehouse, right? So they will incur ordering costs. Okay, it will incur ordering costs. Or on the other hand, right, when your finished product is ready for sale, okay, each time when you try to basically transit your finished product from your warehouse to the retail store, it will also incur ordering costs. Okay, so basically each time when you have to deal with the transition procedure, you will deal with the ordering cost related to the inventory, right? So that's actually very also very important cost, right? And here simply I just call it the cost of placing the order. Okay, so based on the definition, you can easily see that when your order time is increasing, then this type of cost, inventory cost, will be higher and higher and higher. All right. The last one is called shortage cost. Okay, or we say it's cost of running out. That's actually very simple, right? Because each time if you don't actually have inventory, then even if the customer needs those those customer need this product, right? You don't have the product in your stock, then you will basically lose your profit within the opportunity. Okay, you lose your profit in the opportunity. That's why actually shortage cost is also one big important type of cost within for the inventory. Okay, or associated with the inventory. All right, now. Okay, another field of within inventory is called demand types. Demand types. So here, if you since all of you already look at the textbook, all right. So we say that for the demand, actually we separate into 2 different classification or 2 different classes. All right. So one is called independent demand. One is called dependent demand. Okay. So you may wonder what is the difference between independent demand and the dependent demand. Okay. The key essence here, or the key difference here, is very simple. Okay. So although here I list the definition of here, let me give you a quick example of it. All right. So it's very common that for a firm it will produce certain different products simultaneously. All right. Let's say they produce item A, item B, and item C simultaneously, right? Those items are different items. They can be related with each other, or it can be, just independent with each other. Okay. In many cases, we know that firms may just produce some different products. All right. And those different products are not related with each other. Okay, are not related with each other. That's very common. Okay. Then in those cases, we just say this is called independent demand. Okay. But actually, in other cases, okay, the need for one item is actually highly related or even a direct result of the need for some other items. In those cases, we call it dependent demand. Okay, let me give you a quick example for it. Let's say you are producing a car. All right, you are producing a car. Okay, and we all know that for a car, normally for a car, we have how many engine? We need one engine, right? For every car, normally we need one engine. How many wheels? We need four wheels, right? And all right, how many tires? Still four tires. Okay. Suppose as a car producer, okay. Suppose you are a car producer, okay. You produce the engine and also the wheel and also tire simultaneously because you want to produce car, right? You want to produce car, all right. And in order to produce a car, you need to produce one engine, four wheels, and four tires. Okay. Now suppose the customers order, let's say, 20 cars. Then immediately, okay, you know that how many engines you need to produce, how many wheels you need to produce, and how many tires you need to produce, right? So let's say the customers order 20 cars. How many engines you need to produce? 20, because every car has one engine, right? But how many tires you need to produce? You need 20 times what? Times 4, which is 80, right? Because every car has 4 tires. That's why that's corresponding to the dependent demand situation. Because when you produce a car, the need for producing an engine, okay, is highly correlated or is even directly correlated with the need for other item. Okay, for example, tire. Okay, for example, tire. That's how we basically separate, the demand for different items production into, independent demand or dependent demand. Okay, the key sense here is quite simple. It's quite simple. If you have any other question, just let me know. All right. Now let's move back to the inventory system methods. Okay, I already kind of give you a good sense about the key difference between single period inventory model and multi-period inventory model, right? As I said, so if your order event or orders decision, okay, is once, okay, you only need to care about one-time inventory, order, let's say inventory order decision. This is corresponding to single period inventory model, okay? But if you have to care about, multiple times order decision, this is corresponding to multi-period inventory models, okay? Within the multi-period inventory model, we introduce fixed order quantity model and fixed time period models. The key difference between fixed order quantity model and fixed time period model is that in the fixed order quantity model, okay, each time when you order, the order amount itself is fixed, okay? But the time window between two different order decision or two different order event, okay, is variable. But in contrast to that, in the fixed time period model, okay, the time window between two order events is fixed. But each time when you order some amount, the order amount itself is variable. Okay, so you see that no matter in fixed order quantity model or within the fixed time period model, one thing is fixed and one thing is variable. Make sure you understand which thing is fixed in which model and which thing is variable in which model. Okay, so and we will detail to talk about these two models later. Okay, here let's focus on single period inventory model. As I just said, okay, in the single period inventory model, you only care about this single order decision, okay, in order to maximize your profit. Now, let's detailedly look at the single period inventory model, okay. Let's use the very broad and very common application to illustrate the single period inventory model, okay, because I know that if we directly just use the the math equation or the math problem to talk about it, it will be a little bit too abstract. Let's use the application to illustrate the single period inventory model. Now let's consider a problem, okay, of deciding how many newspapers to put in a hotel lobby. Okay, so suppose you are a hotel owner. Okay, hotel owner, and at every morning, okay, every morning, let's say 4 a.m. Okay, you will buy certain amount of newspaper from the newspaper publishers. Okay, from newspaper publisher. Okay, and you put it into the hotel lobby. Okay, and when the customer, when those visitors in your hotel, when they wake up, okay, if they are interested about the everyday newspaper, this day's specific days newspaper, they may buy from you. Okay, and then you may basically earn some money. Okay, due to selling this newspaper to your customers. All right, but here is the issue. Okay, you can even imagine that, right? At the 4 a.m., you cannot fully understand or fully predict how many customers in my hotel will buy the newspaper, all right, or buy today's newspaper, basically, right? You don't know that, okay? Actually, the real number will only show after what? Basically, after, or we can say the real number will only show at the end of today, okay? So we can say you may buy 20. Let's say you may buy 20 newspapers, okay? But in the end, 18 of them, okay, 18 of them is sold. Then basically you know that the market demand for this newspaper, okay, within your hotel is 18, okay? Of course, the market demand can be over 20, okay? But in those cases, since you only have 20 newspapers, you lose some profit in opportunity. You see the trade-off between these two, right? So the amount of newspaper that you should buy, from the newspaper publisher, okay, is a very standard single period inventory model problem, okay? Because the trade-off here is what I list here, okay? You don't want to order too few papers from the paper publisher, okay? Because if you only order too few paper, you may lose those profit opportunity. Okay, because even if those customers in your hotel need today's newspaper, but if you don't have those inventory in your hand, right, the customer cannot buy it, right? Then you lose those profit opportunity. Okay, but on the other hand, if you buy too many papers to be ready for sale, okay, then in those cases, maybe not so many customers need today's newspaper. Then for the newspaper that you didn't sell, you will lose some money because you still need to buy it from your newspaper publisher at a lower price. But since this lower price is not zero, you need to pay some, uh, price pay some price for ordering this newspaper from the newspaper publisher. Okay, so that's why here we can view newspaper as your inventory because you try to sell it to your customer, but since you don't know what is the exact market demand at the beginning of this morning, right? So you don't want to basically purchase too many newspaper from your newspaper publisher. Also, you don't actually want to, purchase too few papers from your newspaper publisher. Okay, but what is the optimal newspaper, amount of newspaper that you want to purchase from your newspaper publisher? Okay, we can use model to help us, solve this type of problem. Okay, now let's move to the more specific math problem. All right. So now we know that actually the market demand is not realized at the morning, right? So definitely we are facing certain risk, okay, that our inventory will running out basically, right? We're trying to we're not actually getting rid of this risk, but we are trying to make this, uncertainty or this risk at an appropriate or acceptable level. Okay, we're trying to make it at an acceptable level. Okay, how to determine this specific risk level? This is what we will also investigate on by using certain applications. Okay, Now, even before we start to talk about the specific, single period inventory model, or here we can further quote newspaper model, okay? Or in the operations management research field, we call the news vendor model. Okay, it's a very standard model, but it actually captures the key idea of a single period inventory model. That's why it's very famous in operations management research. All right, but even before we look at the application, okay, since here we will introduce some statistical tools. Okay, I will give you a brief description about the statistical tool that we need to use within this type of specific problem. Okay, so I know that probably most of you already took BStat in the past semester or last year. All right, so but here in order to give you kind of a recap, okay, I will briefly talk about the thing or the statistical thing that we would need in this type of the problem solving. All right. So all of you guys may still remember that in the BStat course we talk about the normal distribution. Okay, the normal distribution, and as you can see within the slides, all right, this bell-shaped curve is exactly a normal distribution. Okay, so what is the normal distribution? Okay, so the x-axis basically are representing all different type of the possible outcome, or different type of possible outcome. Okay, in our application, you can view it as, let's say, the market demand realization of certain products. Okay, the market demand of realization for certain product, okay, is basically x-axis numbers, the different x-axis numbers. Okay, so for normal distribution, you see this is like a bell-shaped, right? And you see at the middle point, okay, the middle point is basically corresponding to the peak of this curve. Okay, the peak of this curve. Okay, what is mean? The meaning of this point is that basically at the middle point, okay, or at the mean point, the probability of happening is the highest. Okay, the probability of happening at this middle point is basically its highest. Okay, and you can see that by if we view this vertical line, okay, the left hand side and the right hand side is symmetric. Okay, if you fold based on this vertical line, okay, you can see that these two parts they will coincide with each other perfectly, right? They will coincide with each other perfectly. Okay, and you can see that when this number moving away from this middle point, if you look at the corresponding, the height is becoming shorter and shorter, right? What it means? It means that the probability, okay, of that specific number happening, okay, of that specific number happening is becoming lower and lower when this number is moving away from the middle point. Okay, those are very clear and very straightforward features of the normal distribution. Okay, now let me ask you two questions to help you basically remind your statistical tool that you learned within the normal distribution. Okay, so normally we use only two parameters that we can capture. We can already capture this normal distribution. Which are those two parameters? Those two parameters are mean and also the standard deviation. Okay, what is mean? Mean basically is the middle point. Okay, it's the middle point. Okay, what is standard deviation? What standard deviation measures? Standard deviation measures how this curve will disperse. Okay, away from mean. Okay, away from mean. So you see that once you locate the mean and once you locate how it will disperse, then you basically can plot the whole normal distribution very smoothly or directly. Okay, so we say that the normal distribution only use two parameters. We can already capture this normal distribution. Okay, that's actually very straightforward. Okay, and further, we say that no matter which type of normal distribution, okay, We can say this is a standard normal distribution or general normal distribution. But no matter it's a standard normal distribution, normal or general normal distribution, okay, what is the total area? Okay, what is the total area under this curve? Remember that? What is total area? The total area is 1. Why the total area under normal distribution is 1? Okay, because it's corresponding to the probability of different possible outcomes happening. Okay, the total probability of different outcomes happening is 1. It's always equals to 1. That's why the area, you see, the whole area, okay, under this red curve is 1. Okay, then let me ask you another question. What is the half of this area? Let's say half of this bell shape. What is corresponding value? It should be half of 1, which is 0.5. All right, 0.5. So this part, the area should be 0.5. Then how about this part? This should also be 0.5. Okay? All this stuff, the statistics stuff related to normal distribution, I think you should already learn that within your BStat course. Okay? Here, I just give you a brief illustration if you already forget about something related. Okay? So if you're still a little bit confused, go back to look at your slides for your BStat course. And if you still have some question, please let me know. Okay? Please let me know. Okay. Now, the normal distribution will be used in this specific type of problem. Okay? And I will further let you know how to use Z table to basically get some specific Z value or probability value that we will use within this specific type of problem. Okay? Don't worry. I will lead you guys to detailedly go through this stuff. All right? Now, let's get back to our context. As I say, for no matter which type of normal distribution, right, we can just use 2 parameters to capture the whole idea of normal distribution, which are mean and standard deviation. Now, let's get back to this specific question. Okay? Now, suppose that since you are a hotel owner, right? Let's get back to this example. You are a hotel owner, okay? You don't know exactly what is the market demand for this specific morning, okay? But based on your previous experience, okay, at least you know certain, you have some experience, right? You have certain idea about probably this newspaper, okay, will be sold by how many amounts, okay? You can sell how many amounts of your newspaper, all right? Suppose that based on your experience, all right, you figure out that the amount of newspaper that you can sell every day in the morning is following a normal distribution, okay? And in this normal distribution, the mean is 90 papers, and the standard deviation is 10 papers, okay? Suppose that although you don't exactly know what is the paper amount that you can sell this morning, you at least know certain statistical, reference, okay, about newspaper selling based on your previous experience, okay, as a hotel owner. So you know that the mean is 90 papers and the standard deviation is 10 papers. That's why in this specific normal distribution, you see that as I show here, the middle point is how much? It's 90, right? It means that, okay, 90 papers at the middle. If you look at this vertical straight line, right? This height is what? This height is longest, right? Means that the probability of 90 copies or 90 papers, okay, that will be sold to the customer is highest, okay? The probability that 90 papers will be sold is highest. That's it, okay? And the standard deviation is 10 papers. That's basically capture how this probability will disperse to some numbers away from 90, okay? So suppose that we want to have an 80% chance of not running out, okay? In this simple case, let me directly tell you that we want to have an 80% chance of not running out, okay? Later in the more complicated case, we will basically calculate this specific number based on some other criteria. But let's do it step by step. In this specific example, this easy example, let's say I directly tell you that we want an 80% chance of not running out. Okay? Then my question is very straightforward. How many copies of paper should I purchase as a hotel owner in order to maintain this 80% of chance of not running out? Okay? Let me repeat the question again. How many copies of the newspapers should I purchase as a hotel owner in the morning in order to prevent that there's an 80% chance my newspaper will not running out? We're not running out. Okay? So let's use certain statistical tool to help basically solve this problem. Actually, it would be very easy. Okay? Before we even start to use the specific studies tool, by just looking at this plot, okay? As I said, what is the total area under this red curve? It should be 100%, right? Because the probability of all different possible outcomes, if we add all them up, right? This is, you see, this line is corresponding to 90, okay? Maybe to the left of this, it can represent 89, this is representing 91 as the right-hand side, right? The total probability, okay, of different possible outcome is 100%. That's always true, okay? That's always true. Then, since 90 is the middle point, and we know that the left-hand side is symmetric to the right-hand side, what is the area to the left-hand side? It should correspond to 50%, right? It corresponds to 50%. Okay, but now here, what we are asking is to maintain an 80% chance of not running out. 80% chance of not running out. Okay, so since this is corresponding to 80% chance of not running out, okay, within the normal distribution, from the most left-hand side to the middle, okay, this area is representing 50%. Okay, but what we want is not 50%. What we want is 80%. Then we have to continue to move to the right-hand side, which is this small z, okay, which is corresponding to this small z value. Right now, we don't know this specific z value here, but this small z value is what we want, is what we need to calculate, all right, in order to get, in order to further get the specific number of the papers that we need to purchase in order to maintain this 80% chance of not running out. Okay, so you can see that the green area, okay, the whole green area is actually corresponding to this 80% of the chance that we will not run out for today's newspaper. All right, it should be very straightforward. And then we know that, okay, this is corresponding to this 80% of chance of not running out. What is the specific z value? How to calculate the specific z value? Okay, that's actually corresponding to the statistical tool that we need within the normal distribution in order to figure out this z value. Okay, how to get this z value? We actually have two ways of doing it. All right, one way is basically directly use the Excel to do it. The second way is basically use the z table. Okay, I was basically recommend you guys to do both versions. Okay. I say that basically by using Excel it's easier. All right, by using Excel it's easier. It's quicker. All right, but since in our exam, all right, I will require you guys to use z table. You also need to know how to use z table to get these results. All right, actually using z table to get the specific z value, like I just said. Using z table to get the specific value is also very simple as long as you understand how to do it. Okay, it's just a checking process, and it probably just take a few seconds to finish the checking procedure. All right, but how to do it, I will do it for lead you guys to get this specific value within the z table just in a second. All right, so before we do that process, okay, before we do that process, the checking process, all right, the equation basically is showing here. The probability of this z, which is less than or equals to small z, equals to 0.8. Okay? it means that in the z table, okay, when z is less than or equals to some specific value, okay, the corresponding probability equals to 0.8. Okay, let me repeat that again. In the z table, what represents z? Z is corresponding to standard normal distribution. Standard normal distribution, all right? The standard normal distribution tells you that basically when mean equals 0 and mu equals 1 is corresponding to standard normal distribution, all right? So here we know that the equation basically tells that, okay, when z is less than or equals to a certain value, the corresponding probability equals to 0.8 because we set it, right? We maintained it as 80% chance of not running out. That's why here, since the 80% chance is equivalent to 0.8, 0.8, all right? And in this specific equation, all right, we know that the probability of z which is less than or equals to some specific value equals to 0.8, right? But we don't know this specific value. That's what we need to check from z table. Okay, now let's move to z table. Move to z table, okay? In the z table, this is a very standard z table, okay? In the z table, the row and the column provides you the specific z value, okay? The inside cells provides you the probability, okay? In this specific case, okay, what we know is that, what? What we know is basically the probability. What we want to find is the specific z value, right? That's actually very straightforward. Okay, now, since what we know is the specific probability, but what we try to find is the z value, then how to check the z table? Very easy. We just look at the inside cells and try to find out the value that is most closest to 0.8. Which one is the closest? You see, 0.7995. This value is not exactly 0.8, but it's the closest number shown within the z table, right? That is the closest number shown within z table. It's close enough, okay? Then we already figure out the corresponding probability. What is the corresponding z value? Very simple. You just look at, since this is at the intersection of certain row and column, right? You look at the corresponding row, which is 0.8. Okay, right here is 0.8. And then you look at the corresponding column, which is 0.04. Okay, 0.8 plus 0.04 is 0.84. Okay, it's 0.84. So, okay, but just going through this very simple procedure, you can figure out that basically the probability, since the probability z which is less than or equals to some specific value equals 0.8, you figure out that the z value is 0.84. Okay, 0.84. Very simple. All right. Yeah. So you see that from Excel, you will figure out this is 0.84162, but from the z table, this is 0.84. Okay. You see that these two numbers are very similar. The reason that here, this is 0.84, this is 0.84162 is because that in the z table we accurate to 2 decimal points. That's why here you see this is 0.84. If you accurate this number to two decimal points, this is also 0.84. Okay, so they are actually equivalent. So this is 0.84. Okay, so after you get the z value, okay, you are approaching to the final result. Okay, but it's not equivalent to the final result. Remember what we want to get. Okay, within this question is that in order to maintain 80% of the chance that we were not running out, how many copies of the paper we should purchase, okay, from the newspaper publisher as the hotel owner. Okay, that's our question, right? That's the thing that we want to generate. Okay, so we already use the z table to figure out this z value. Okay, but we know that, okay, this is actually also going back or connected with your course material related to your BSTAT course. Okay, we know that z table is only corresponding to the standard normal distribution. The standard normal distribution is basically when mu is 0 and sigma is equals 1. But of course, we know that in our situation, our mu is not 0, it's 90. Okay, our standard deviation is not 1, it's 10, right? So we know that our normal distribution is not a standard normal distribution. It's called a general normal distribution. Okay, only when mu equals 0 and sigma equals 1, we say, okay, this is a standard normal distribution. In all other situations, this is corresponding to general normal distribution. Okay, let me remind your mind from the BStat course. All right. So here, okay, but we know that this is a general normal distribution, but we can still use z table to figure out this corresponding z value, okay, as a reference. But remember, since this is not a standard normal distribution, it's a general normal distribution, what you need to do in the last step is to going back from the standard normal distribution back to the general normal distribution. So you have to transform, okay? Z is corresponding standard normal distribution. You have to transform back to the corresponding general normal distribution statistic, okay? This general normal distribution statistic, okay? Here I already provide you the equation of transformation, okay? The equation of transformation is quite simple. X equals to mu plus z times sigma, okay? Mu plus z times sigma. This z showing here is exactly the z value that I show here, okay? This actually should be a small z, not large, this small z, all right? It's small z. So you see that's why here 0.84, okay, is for z value, okay? And what is mu? Let's get back to our example. Mu is 90, right? Your middle point is 90, right? What is a sigma? Sigma represents the standard deviation, right? That's actually very already emphasized many times within the BStat course. Sigma is represents the standard deviation. Do I tell you the standard deviation? Yes. The standard deviation is 10 papers, or the numerical value is 10. That's why here you see mu plus z sigma equals to 90 plus 0.84 times 10. Basically, I just plug into this corresponding value into this equation in order to get our final product, which is x. Okay, x is corresponding to our final product, our final result. Okay, which is how many copies of paper the hotel owner should purchase, all right, in order to maintain 80% of this, running out. All right. Then the final result you get would be 99 papers. Actually, if you directly calculate this, the result should be 98.4. But we know that for a newspaper, you cannot buy 0.4 paper, right? That's why here we should run up to 99 papers. Okay, we should run up to 99 papers. Okay, so finally, by getting this result, you know that okay, in order to maintain this 80% level of not stocking out, the hotel owner has to buy 99 papers. Okay, has to buy 99 papers. Okay, you see that this specific value is higher than 90. Okay, if you only buy 90, let me ask you this question. If you only buy 90, okay, then what is the corresponding percent of the level of not stocking out? If you only buy 90, you maintain a how much percent level of not stocking out? It's 50%, right? If you only try to maintain a 50% level of not stocking out, you just buy 90 papers. But if you are trying to maintain an 80% level of not stocking out, you need to buy 99 papers. Okay? Then simply I can change this number to any other numbers. Okay? You can actually try yourself. All right? If we want to maintain 90% level of not stocking out, what would be the corresponding copy of papers that we need to prepare? Okay? If we are trying to maintain a 95% level of not stocking out, what is the corresponding copy of papers? Okay? If you are trying to maintain, let's say, just a 40% level of not stocking out, then what is the corresponding copies of paper that we need to basically buy from the publisher? Okay? Try yourself, and if you have any question, let me know. All right? Now, that's the simple version of this single period model. Okay? Now let's move to a little bit more complicated version. All right? But actually, the essence is still the same. It's very simple. Remember that in a simple version, I directly tell you what is the level of the not stocking out, right? Directly tell you which is 80% level of not stocking out in that specific case. Okay, that's basically exogenously given by the context. All right, but instead sometimes I may not directly tell you the corresponding level of not stocking out. Okay, instead I may tell you certain costs. You have to calculate the most appropriate level of not stocking out yourself. Okay, not okay. So here I give you the equation directly. It should be very, very straightforward. Okay. P basically represents the probability of not stocking out, right? Very simple. P represents the probability of not stocking out. P equals to what? Here we use the less than or equals to, okay? But in the marginal case, you can directly view it as equal, okay? You can directly as equal because when it's equal, it's actually corresponding to the optimal situation. And the corresponding value is exactly what we want within this specific case, okay? And on the right-hand side of this equation, what is the CU? As I show here, CU represents the cost per unit of demand underestimated. Or equivalently, we say the cost of understocking. Okay, the cost of understocking. Okay, cost per unit of understocking. And CO, you can even imagine what is CO, right? The CO is cost per unit of demand overestimated, or simply we can say cost per unit of overstocking. Okay, so simply let me describe it. What is the cost per unit of demand overestimate and the cost per unit of demand underestimate? All right. So let's say you purchase 20. Okay. Let's say you purchase 20 papers. Okay. If the market demand is 20, exactly 20. Okay. Then you perfect match with market demand, right? You perfect match with market demand. Okay. But let's say if you purchase 19. Okay, if you purchase 19, but the market demand is 20, are you facing cost of understock or cost of overstock? You are facing cost of understock, right? Because you only purchase 19, but the market demand is 20. Then you can only fit that 19 market demand. For that additional market demand, for that additional 1 unit of market demand, you cannot do it. So in this situation, you are facing cost of understock. Okay, the cost of understock. Basically, the cost is the profit in opportunity. All right. But on the other case, let's say if the market demand is still 20 units, but if you purchase 21 units from your publisher, okay, in this kind of situation, you are facing the cost of overstock. Okay, you're facing the cost of overstock. Okay. Because for this 21 units that you purchase from the publisher, you definitely can sell those 20 units for the market demand. But for that additional 1 unit, you cannot sell it. All right. But since you purchase from your publisher, you incur the cost in order basically related to purchase from your supplier, right? So that's the cost of the overstock. Okay. So the derivation of this equation, okay, actually will take a few time to go through all the things. Here, I won't actually include within our chapter slides, but if you are interested about how to get this equation, P equals to cost of understock divided by cost of overstock plus cost of understock. Okay, if you're interested about this equation, please let me know. Okay, I can show you how to derive it. Okay, it's actually very interesting. All right. But the final equation shown here is already straightforward, all right? And basically, the probability of not stocking out just equals to, we can view it as equal, all right? As the marginal case. So just equals to the cost of understock divided by cost of overstock plus cost of understock. That's it, okay? So in the question, if I directly tell you what is the cost of overstock and what is the cost of understock, or if I tell you some information related to these two things, and you basically can just simply calculate the cost of overstock or the cost of understock. Okay, after you get those two things, you can directly calculate what is the optimal probability of not stocking out very easily. All right, now let's use the quick example. All right, an application example exactly actually from the textbook to illustrate the single period inventory model. Okay, so this is actually example 11.1. All right, and you can see that this hotel near the university always fills up on the evening before football games, and history has shown that when the hotel is fully booked, the number of last minute cancellation has a mean of 5 and a standard deviation of 3. The average room rate is $80. Okay. When a hotel is overbooked, the policy is to find a room in a nearby hotel and to pay off the room for the customer. Okay. So this usually costs the hotel approximately $200. You see, this is higher compared to $80, right? Since rooms booked on such late notice are very expensive. So how many rooms should a hotel overbook? Okay. First of all, intuitively, let me ask you why the hotel should overbook. The reason is very simple. Okay, because you see, from the history, we know that certain customers they may cancel their book, okay, within a hotel at the last minute. Okay, they may cancel it at last minute, and this corresponding statistics has a mean of 5 and a standard deviation of 3. You can see this is following a normal distribution, right? Because I tell you the mean is 5, the standard deviation is 3. Okay, so here we know that from the history, the hotel already know that, okay, it may happen that some customer may cancel their book at the last minute. Okay, if they cancel it, basically, if the hotel, all right, doesn't have other option, doesn't have other visitors, the room will be empty. They will lose some profit opportunity, right? That's why, all right, in order to compensate their profit themselves, right, they are trying to overbook a little bit, okay, in order to deal with this kind of last minute cancellation, okay? But the hotel doesn't want to overbook too many. What is the reason? Why the hotel doesn't actually want to overbook too much? Okay, the reason is that if you overbook too much, if most of them come, okay, and if you cannot arrange a room for every one of them, you have to pay the overbook fee, right? Because you have to arrange them to some other hotel and pay this corresponding fee. And you see that this corresponding fee is $200. That's a kind of cost showing here. And you see that this $200 is much higher than the original rate, which is $80. Okay, so even before we using our single period inventory model, you can already see that there is a trade-off here, okay, between overbooking too little or overbooking too much, right? If you don't overbook, you basically lose some profit opportunity because some of the room may be empty due to the late minute cancellation from some customers, okay? But if you overbook too many, if most of them comes, you will pay $200 for their arrangement fee. This arrangement fee is higher than the original room rate. That's why you have to deal with this kind of situation. Okay? Very simple. Let's look at this, how we use our single period model to deal with this situation. Okay? So first of all, the basic facts are already listed here. All right? So what is the mean demand of those late times cancellation? Is 5. All right? Very straightforward. What is the standard deviation? It's 3. Okay? Since we are talking about the cost of understock or cost of overstock, right? We already integrate these two things within our context. Okay? What is the cost of understock? Think about this. In this specific case, what is the cost of understock? The cost of understock in this specific case means the cost, okay, of having an empty room. due to the last minute cancellation. Okay, due to the last minute cancellation. What is corresponding cost? The cost would be 80, right? Because if a visitor comes, he will pay $80 in order to reserve a room. But if due to the last minute cancellation, right? If this customer doesn't come, then without probably knowing the situation, this room will be empty at that time, right? So you will lose $80 for this empty room, for this profit opportunity. That will be the cost of understocking. Okay, the cost of understocking is $80. Okay, then what is the cost of overstock? In this specific situation, the cost of overstock is very straightforward. The cost of overstock basically, okay, now let's say give you a quick example. Let's say we have 4 rooms, okay? But 5 different families, they come, all right? Then 4 of these 5 families can be arranged in our own hotel. For another 1 family, you have to arrange them to the, let's say, other hotel because you only have 4 rooms. Okay, what is corresponding cost? It should be $200 directly. Okay, so this will be a simple case because in this case, I directly tell you what is the cost of understock, okay, and what is the cost of overstock, okay? But in some other cases, I may give you some related information, okay, and you may calculate yourself. Based on the fact, okay? But the key sense here is very simple, okay? So no matter it's overstock or understock, okay, it's basically the comparison between the inventory and market demand, right? Between the inventory and market demand. So when inventory amount is higher than the market demand, okay, you are facing the cost of overstocking, okay? And if the inventory amount is less than the market demand, you are basically facing the cost of understocking. So if you keep that key sense in your mind, okay, no matter what kind of application or context I change, okay, user intuition, you will easily figure out what is corresponding cost of understock and the cost of overstocking. Okay, so in this specific case, cost of understocking is 80, cost of overstocking is 200. Okay, so based on our equation, it's very easy to get the corresponding probability. Probability of what? The probability of basically, you can say a probability of not running out, right? Not running out. So here you see the probability here is 0.2857. Okay, so basically in this specific case, we're trying to maintain how much percent of what percent level? 28.57% level. Okay, we're trying to maintain this level, given those information within the context. Okay, all right. Then basically we just repeat the whole procedure that we use within a simple case, right? Remember in the simple case, what we did basically, I directly tell you that we try to maintain at an 80% level, right? And then we do this whole process and it gets the corresponding X, which is 99 papers, okay? But here, instead of directly telling you this is, you see here this is 80%, right? But here in our more complex example, instead of directly telling you what is the level that we try to maintain, you use this equation to calculate yourself based on the cost of understock and cost of overstock, and you will see that the optimal level that we try to maintain is 28.57%. All right. So since this is 28.57%, all right, then what is the next step? Exactly the same thing, right? In the next step, we are basically trying to guess the corresponding z-value. Okay. You can use the Excel to get the corresponding z-value, which is showing here, which is 0.56599. Okay, or we can directly use the z-table to check it. Let me go through this again. All right, since this is 0.2857, now let's get to the this corresponding z-table. Right, you see that z-table actually have 2 parts, part A and part B. All right, part A basically are showing those probabilities that are having smaller value, which is lower than 0.5. Okay, basically it's corresponding to the left-hand side of the normal distribution. All right, and part B is basically corresponding to the probability that are having higher values, which is higher than 0.5, and they're basically they're corresponding to the probability at the right-hand side of the normal distribution. Okay, so here what we are trying to dealing with, the specific number is, let me look at this 0.2857, right? 2857, let's look at this. So 0.2857, of course we need to look at the part 1, right? Where's 2857? 2857 is, you see, it's similar like this, right? It's similar like 0.28443. This is the closest number. So if you look at the corresponding row, it's the negative 0.5. If you look at the column, it's 0.07. So if you look at the intersection, it should be negative 0.57. So it should be negative 0.57. Okay, negative 0.57. Okay, so yeah, you see, it should be negative 0.57. Okay, she should be, yeah, negative 0.57, right? Yeah, but here you see, by using Excel, it's actually keep more decimal points. But if you only keep 2 decimal points, it should be negative 0.57. Okay, that's why here, when we try to calculate the final result, okay, we use the mu. They use the here the slide use the x bar. That's the same thing. Mu plus d times sigma. Okay, mu plus d times sigma. What is mu? Mu should be, mean is 5, right? Mean is 5. What is sigma? Sigma is 3. Great. All right. Then 5 plus the small z value, that's what we just get, is negative 0.56 times 3 in order to get 3.32. Okay. Yeah, so in this case, we are trying to basically kind of a little bit, so you see, in this case, we're trying to become a little bit conservative because, if we overbook 4, we may incur more costs. That's why here we run down to 3 reservations. Okay, so finally, the result here, how many rooms should the hotel overbook? 3 instead of 5. Okay, because we are trying to, why you see here the room should the hotel overbook is only 3 instead of 5, because we are trying to kind of mitigate the loss due to the overbook, right? Because each time if the overbook happens, we will cost $200. That's a big amount. That's why we kind of overbook a little bit, right? But not as much as 5. Okay, that's the whole reasoning. All right, so yeah, this is exactly the example 11.1, and yeah, these are just some other details, but this is not that related to our main focus. All right. So here I just list some other applications that may frequently use single period model. So actually, the single period model itself, it applies many different contexts. All right. So, but the key is exactly what I just mentioned. All right? So as long as you have the similar situation, you can use the single period model that help you to get a better improvement on the inventory system. Okay, that's actually very useful. Okay, here list some of those applications like overbook of the airline flights, right? So airline companies sometimes they may overbook it. Many frequently they will overbook in order to protect from losing some profiting opportunity. All right, or they may order of clothing and other fashion items. Those kind of factory, those kind of industry, they may also use this single period model. All right, they may overorder some clothes in certain cases, or some other all-time order for events such as the T-shirts for a concert. All right, T-shirts for a concert, because after this concert, this T-shirt, you see, the disposal rate will be very low, right? Because after this concert, this event already happens, then the business value will become much lower, right? So those are very standard single period model applications, but it doesn't mean that we limit to all these different applications. Actually, it will apply to many different applications. All right. So keep your mind about your single period model, and we can actually apply in many different aspects. All right. So this is the part 1 of our inventory management video. All right. We will end at the single period model. And in the part 2 of the chapter 11 inventory management video, we'll continue to talk about the multi-period model. Okay, so see you soon.